Hey y'all! In this video, we're going to discuss our Z0 position and XY datum position within the Vectric software, then take that information outside onto the CNC router and apply it to a piece of material. When we first set up a job in our software, we decide whether it's going to be single-sided, double-sided, or a rotary job. We enter our material sizing here, select our units, be it inches or millimeters. Then we have a couple of decisions to make. We need to set our Z0 position and our XY datum position. Before I get into either of these, let's discuss what this actually means. These are references to the Cartesian coordinate system. Now, the Cartesian coordinate system has been around since the 1600s, and it is basically a way to plot points or objects on a plane that have a known location. Looking at a Cartesian coordinate plane, this is the basic drawing. We have an x-axis running from side to side, and we have a y-axis running from, in this case, bottom to top. You can see it's divided up into quadrants, and this center, or XY datum position, or the origin point, is our 0 point. Movements to the right of the 0 point are positive numbers. Movements to the left are negative numbers. Movements up above 0 are positive numbers. And movements down below 0 are negative numbers. There is a lot more information on the Cartesian coordinate system on the internet. If you do a search for Cartesian coordinate system on Google or on YouTube, you will find more resources than you probably will ever want, let alone need. It's just important that you know this is the system that is used by all CNC routers and all CNC router control software. So, when we get back here into Aspire, we have a couple of decisions to make actually. Are we going to set our Z0 to the material surface, or are we going to set it to the machine bed? Most of the time you will see me working from the material surface. Generally speaking, I use this setting when I'm carving down into the material without going all the way through it. I will usually set my Z0 position to the material surface when I'm V-carving, when I'm carving a 3D model, or when I'm pocketing. I will use the machine bed when I'm doing a profile cut that cuts all the way through the material, or if I'm drilling. Basically, this is your choice, but we will get further into this in future videos. The XY datum position simply means where are we setting that XY 0 point or the origin. Right now I currently have it at the center, and I tend to use the center when I'm drawing my design. Before I start calculating tool paths, however, I will come back and I will change that to the bottom left corner, because that's where I set my X and Y 0 outside on the machine. This is a personal choice. You can choose the center. You could choose any corner of the material. This is one of those cases where there truly is no best option. I use all of them and will continue to use all of them. The project will tend to dictate where to set your XY datum position. The most common, however, is going to be the bottom left corner. So after getting our material set up, we'll click OK. Then we'll draw our design. We'll come over and calculate our tool paths, preview the project, then save G-code. Once we've done that, we're ready to go outside onto the CNC, home the machine, then set our X, Y, and Z 0 and start cutting. Okay, out here on the CNC router, we're going to apply everything we just talked about inside to the machine itself and to the material. Now you'll notice I have this second piece of material mounted over here the same way that I've mounted this piece of material, my workpiece. Well, let's just ignore this for a few minutes. I'll get into the purpose of this pretty soon. Another thing that's important to understand is that no matter what your control software is, your CNC router has two separate sets of coordinates. You probably heard them referenced. That is machine coordinates and work coordinates. Now again, I'm using the Avid CNC profile in Mach 4. Your screen will probably differ. All control softwares, no matter who it's made by, have two sets of coordinates. That is machine coordinates and work coordinates. And I can tell which I'm using at the time in this profile of Mach 4 by looking at this button up here. And again, I'm sorry, I don't have screen capture software on this computer. This is the best I can do. Right now I am in work coordinates, and I can tell this because the button is labeled switch to machine coordinates, and this bar here is black. Now if I move my cursor up and I switch to machine coordinates, that bar turns into a red flashing LED, and my button now reads switch to work coordinates. This is letting me know that I am in machine coordinates. To go back into work coordinates and watch my DROs here, digital readouts, watch them. I switch to work coordinates and they change. Machine coordinates are in reference to the physical limits of the machine. Work coordinates are in reference to the physical dimensions of the material. Both are absolute coordinates. In machine coordinates, my 0 point when I home my machine is the bottom left corner of the machine. If I were looking at this from above, this is the bottom left corner of my CNC router. That is X0, Y0 in machine coordinates. And all coordinates after that are in reference to this corner. In work coordinates, when we set our XY datum position in the Vectric software, they were in reference to either the bottom left corner of this piece of material or the center of this piece of material. You will very rarely work in machine coordinates. In the few years that I have been working on CNC routers, I have used machine coordinates only a handful of times. 999 times out of 1,000, you will be working in work coordinates. It's important that you understand the distinction between machine coordinates and work coordinates, however, because that's how you create work offsets and fixture offsets, is using those machine coordinates. It's also important that your controller software knows where this spindle is at all times. That's why we home the machine. When you home the machine, the gantry moves forward to its limit, your x-axis moves to its limit, your z-axis raises to its limit, so that the controller software knows where that spindle is in reference to the table of your CNC router. Okay, for our first sheet that we created, which was XY datum position in the center of the material, all I'm going to do is take a straight edge and I'm going to line it up on the corners of said material, and I'm going to come over here somewhere close to the center with a very sharp tip on my pencil. I'm going to strike a line. Then I'm going to do the same thing coming from the other direction. Just line it up on the corners, hold it down firmly, and strike a line. Now, that mark is much bigger than it needs to be, but hopefully you can see that. This is my XY datum position according to VCarve or Aspire. According to Mach 4 or your controller software, this is XY0. So now how do I set my CNC router to XY0 right here? Well, that's best accomplished with a bit that has a sharp point to it. So I have a 90-degree V-bit here, and this is what I'm going to use to set my XY0. I'm going to go ahead and put it in the collet and put it in the spindle, just hand tight. It doesn't have to be wrench tight to set XY0, because that's not the bit that I am going to use in the first tool path. So I'm just using this because it has a nice sharp point that I can line up with the center of these two marks. A lot easier than I could with a 1/4 inch end mill, etc. So let me go ahead and get that done, and we'll go from there. Okay, you'll notice that I use a mouse pad down on the surface of the material underneath the bit. That's simply because I have dropped a bit or two and damaged them. So that's to protect the bit should I drop it, should it slip out of the collet. So now what I'm going to do is I'm going to bring my z-axis down closer to the material. I don't want it to touch, but I want to get it close enough to this mark in X, Y, and Z that I can then set my zeros. So let's bring it forward, bring it down. Now it's going to be difficult for you to see, but basically all I'm trying to do is put the point of this bit right over where these two lines cross. All right, there is my X and Y zero. I've got the bit right over the point where those two lines cross. Now I'll come up here into Mach 4 and I will click X0, Y0. My X and Y are now zeroed. Now I need to set my Z0. But in order to do that, I will need to install the bit that I'm going to be using on my first tool path. So let me go ahead and get that done. Okay, now when setting the Z0, there are several ways you can do it. If you don't have a touch plate, I'm sure you've all seen people use the paper on the material method. That is still a viable method, and it does work amazingly well. It's just a little more time consuming and a little less accurate than using the touch plate. Now again, we're going to be setting the Z0 here to the surface of this material. But there is a little bit of a misunderstanding. There is absolutely nothing that says you have to set your Z0 in the same position that you set your X and Y0. The Z0 doesn't depend on this mark at all. Your Z0 depends on whether you have your G-code set to reference off of the material surface or the machine bed. If you have your Z0 position in the Vectric software set to the material surface, then this is the surface that you want to set it to. If it's to the machine bed, you'll set it to the machine bed. Where in X and Y space you do that doesn't matter. This is where this piece comes in, because it doesn't even necessarily have to be the same piece of material. If, for instance, I'm doing a large 3D carve and this entire surface is going to be carved away, after that 3D carve, I don't have anywhere to set my Z0 position to do my profile cutout. That's where this second piece of material comes in. This piece of scrap is an offcut from this piece. This edge here was cut from this edge here. So I know they're exactly the same thickness. They're also mounted in exactly the same way. So I have 2 layers of painter's tape here on this piece, plus a layer of the CA glue. I also have 2 layers of painter's tape and a layer of CA glue under this here. So I can set my Z0 on this piece and it will be accurate on this piece as well. All of this is based on the Z0 position on the material surface. If you have your Z0 position set to the machine bed, this is not necessary and the mounting method is not relevant. One thing that I would encourage you to do, however, if you're in a situation where all of this is not going to be machined away, let's say you're going to do a V carving out in this area, but you're not going to be machining out around the borders anywhere. Pick a spot, and it doesn't matter where. Just pick a spot that's not going to be machined away and draw a little X or make a little circle. Mark it in some way. Then every time you set your Z0, set it at that point. That way, if there's any distortion out here, or you end up removing the spot or carving into the spot where you set your Z0, you have a Z0 position out here somewhere that's not going to be affected by that carve. So, let me go ahead and bring my axes over here. And it doesn't have to be 100% perfect, but we're going to go ahead and bring the Z down slightly. Now I'm going to switch over to incremental jogging. If you did not see my video on incremental jogging, I'll go ahead and put a link to it in a card up in the upper right corner of the screen right about now. Incremental jogging is used to allow me to move any of the axes a specific small amount. So I'm going to go into incremental jogging now, and I'm going to put my jog mode into incremental. Now the first move I want to make is always going to be a Z positive move, and that's just to make sure that the z-axis is responding to these commands. So let me move my incremental jog step to 1/10 of an inch, and I'll do a z positive move. It moved up 100 thousandths. Now I'm going to bring it back down, so we're back where I started. Now I'm going to bring it down closer to this piece of paper. And when I get close enough to where I think maybe if I continue it'll be 10 thousandths will be too much, I'm going to switch over to hundredths of an inch. Again, Z plus move. Z plus move worked just fine. Now I'll do a Z negative move and keep bringing it down. And now's when I'm going to start wiggling this paper. My bit is coming down 10 thousandths of an inch at a time. Now I'm not touching the paper just yet, but I think if I move another 10 thousandths of an inch, it may be too much. So I'm going to switch over to thousandths. Z positive, then Z negative to come back to where I was. Now I'm going to wiggle this paper and bring it down. There's 5, 6, and I can feel a little resistance. 7, there's a little more resistance. 8, 9, 10 thousandths. Looks like I could have come down 1/10 thousandth more. 12. Okay, now I'm feeling a little bit of tension. It's not quite enough to trap the paper. I can still move it. There it is. I can feel, I cannot push it forward, but I can pull it backward. I'm going to call that Z0. So I'll come back up here in Mach 3, and I'll touch 0Z. My X, Y, and Z0 are now set. Now I can raise my bit. And in Mach 4, I can press Go to Work XY0. I'm now ready to turn on the spindle power, put on my dust boot, and I can run my G-code. Now I have purposely reset X, Y, and Z0 to some sort of nonsense so I can demonstrate this method as well. Let's say you have your XY datum position or your origin set to the bottom left corner. This works the same way if you've got bottom right, top left. If you're doing one of the corners of this piece of material, you want to bring the tip of this bit right to that corner. So let me go ahead and bring my gantry forward, my X over, and I'll bring my Z down. Now what I want to do is I want to turn this bit so that I have the carbide flutes running in the Y direction, parallel with my Y axis. And it doesn't have to be perfect, but it needs to be pretty close. Now I'll bring my Z0 down just a little bit. I don't have to be super close. And then I'm going to bring my X over. And when my X is lined up with the edge of that material, I'm going to come up here into Mach 4 and I'm going to zero my X. Now I'm going to turn the flutes of this bit so that it's parallel with the X-axis, and I'm going to bring my gantry forward and set my Y where these flutes are parallel with this edge. So I'll bring my Y forward, bring my X over just slightly so that I can see that they are parallel. Bring my gantry forward and keep nudging it. Just a little bit more. Okay. The flutes of this V-bit are now parallel with the front edge of this material. I'll come up here into Mach 4, 0Y. Now I can lift my bit up out of the way, and now my XY0 is set to the bottom left corner of this piece of material. Now, no matter which method you use, or which position you use, be it one of the corners of the material or the center, once you set your XY0, it will not change for the duration of the project. If I have to do a bit change, if I V-carve the top of this material, then take out my V-bit and put in my end mill to do the profile cutout, I will not reset the XY0. No matter where I have set my XY0, be it the middle or one of the corners. I will only reset my Z0. And the way I'll do that is, once the toolpath is finished running and the machine has come back to the home position, the spindle shuts down, I can then take my wrenches, take out the bit, put my new bit in the spindle, bring it back over to my Z0 point, be it somewhere here or over on this material, and set the Z0 for that bit. So, if you're doing a tool change, you do not reset your XY0. That gets a lot of people in trouble. Once you set your XY0 before running your first tool path, it will not change. So those are the basics of setting your X, Y, and Z0, both in the software and outside on the machine. Now, I didn't get into setting any of these axes zeros with a touch plate. And the main reason is because I don't want to confuse the issue. Every machine, every controller software, and even every touch plate is slightly different. I would highly, highly suggest that you get in contact with your machine manufacturer for their instructions on the use of a touch plate. If you don't even have a touch plate, they would be the people to suggest how to get one, how to make one, or to supply you with one. If your manufacturer doesn't support such things, try to find a support community for your CNC router. If you have a 3040 or a 3018 CNC router, check with the controller software publisher and find out how to hook up a touch plate to your CNC router. Now, this information may seem pretty basic, and it is, but please keep in mind that new people join the home CNC hobby every day. So I'm sure some of you are going to have some questions about this. So today at noon Pacific, 3 p.m. Eastern, I'll be hosting a live Q&A session where you can ask me any question you'd like about anything I've presented in this video or any of my previous videos. Again, that's today at noon Pacific, 3 p.m. Eastern, right here on my YouTube channel. And I've put a link to that live Q&A session down in the description box of this video. Before we wrap up, I'd like to give a special shout out and say a special thank you to all of my channel members. If you'd like information on how to become a channel member, just click that join button Right down there next to the subscribe button, a panel will pop up and a video will play that'll tell you all about channel membership. Don't forget, channel members, to check the community tab for polls, posts, and the link to the next scheduled members only live stream. So I hope to see you this afternoon for the live Q&A session. And as always, whether you subscribe to my channel or not, whether you become a channel member or not, I'd like to thank you very much for taking the time to watch. And y'all take care.